I want to focus on this week on announcements from AWS at the reInvent conference. The TLDR is AWS is looking to compete directly with Microsoft with AI LLM offerings and generative offerings. So to break down some of the announcements, they have announced things such as new LLMs and image generators. Those include LLMs from partners like Anthropic, as well as their internal LLM Titan, as well as the proprietary Titan image generator, which is the first of its kind to have a watermark built in. And that's not just a visual watermark like the ones that you have to pay extra money to have removed from photos somebody takes of you. Those are like statistical watermarks that can be detected by another AI model but are not visible to the human eye. In addition to that, they're adding significant support for RAG, also known as Retrieval augmented generation, which is using vector databases to retrieve data for LLM conversation and generation. So basically a better way to interface with your internal documentation by doing vector search and giving your LLM, your knowledge interface, a way to access large quantities of data in an effective way through semantic search. Amazon is improving support for RAG by making vectorization retrieval from Amazon databases simpler, such that developers don't need to spend the time setting up these vectorization processes and the retrieval processes. The goal is generally to break down database silos and make knowledge retrieval via LLMs faster than ever. The biggest announcement is Amazon Q, which is a new generative AI-powered assistant. All runs on AWS. It's designed for business use, tailored to specific business needs, enabling conversations, stuff like content generation, business insights, and potential actions. You can customize your use of Amazon Q for your business, so different plans based on your user needs, adapting interactions to all of your different users' roles and permissions. Of course, company information will remain private and secure. And Amazon will not use customer content to train the models. Business application examples. Q can assist with tasks like transforming press releases into blog posts or emails, creating social media prompts, analyzing campaign results. We can already use things like ChatGPT for creating these kinds of prompts, but Amazon Q comes with a framework that aligns responses with company brand standards. So the goal is to productionize, make an LLM align with your brand, with your company messaging. There's controls and security. You can define response context, restrict topics, choose whether or not to use trusted company information, supplement with internal model knowledge. They just call it the model's knowledge, which I think is funny. There's fine-grained access controls. You can easily stand up an Amazon Q application. You create the application, select your data retriever, connect data sources like Amazon S3. It has lots of built-in connectors for various popular data sources and enterprise systems. So it's really easy to stand up an Amazon Q instance, and deployment and integration is also rapid. Web experience can be previewed and deployed. You can integrate with SAML to compliant external identity providers for user authentication. And as of today, Amazon Q is available in preview in AWS regions, US East and US West. There's also a GitHub repo for integrating Amazon Q as a Slack bot application if you're interested in that. In addition, unrelated to Amazon Q, but last notes on AWS reInvent. AWS is planning to, and are moving forward to supporting multimodal search, I think is very interesting. For example, a furniture store might want to let their customers search for a sofa by using an image of something they're looking for. Multimodal search, multimodal text and images, and audio probably eventually, and video, we'll see. It can allow users to search for furniture using an image of a furniture and do something like for the closest looking sofa. Or they could ask for, show me what works well with my sofa, and then I'll do some kind of semantic searching of understanding what their room looks like and what kind of sofa might be cool. Of course, this could lead to something more. This could lead to connections with Amazon, like they've already displayed in a demo with agents, where you can say, oh, I want to plan a party, or I want to furnish this space. What do I need to do? Or I want to do some kind of home improvement project. And not only will it list out the steps as LLMs can do, it'll also actually look in Amazon and find all the products that you need and suggest them. So we may be looking at a future not too far from now where you can go to your Amazon Alexa, if you're so inclined, say, I want to build a woodshed and my budget is $2,000. And then in 2 days or less, all of the ingredients to build your own woodshed will show up at the door. Potentially pretty cool. Up next from Stability is SDXL Turbo, which is a text-to-image generation model like Stable Diffusion, like models we've seen before, but this one happens in real time. So the key point is that there are 1 to 4 steps inside the model for creation versus n steps in a Stable Diffusion type or traditional Stable Diffusion generation model. N steps can be 10 steps, can be 20, 30, 50. Basically, this enables, as they call it, real-time image generation, which goes a few different ways, right? It improves user experience, faster generation, especially in interactive applications where waiting for image generation can disrupt your workflow. It can be problematic if you've ever worked with existing image generation tools. It always takes some iteration to develop the image that you want. And most of the time that you spend on that iteration is waiting for the model to generate your images. So it improves that feedback process and helps people get to their final product faster. Greater efficiency is what they're shooting for, right? So faster turnaround times, boosting productivity for designers, for marketers, content creators, etc. In addition, this is a step towards real-time integration with live systems like video games or augmented reality, where delays are not feasible because they'd be immersion breaking. The last piece of news is a new model from DeepMind, or an announcement from DeepMind regarding 2.2 million materials. They call these materials discovered by AI tool GNoME. These materials are crystal structures, and the tool GNoME is a GNN, or a graph neural network, which is a type of neural network designed to process data represented in graph form, which graphs are mathematical structures consisting of nodes or vertices and edges connecting them. And they can be much more complex in the ways that they are connected in a traditional neural network, which generally just has layers of neurons that are connected with each other. A graph neural network can be much more versatile. It can represent complex relationships and structures like social networks, like transportation networks, and of course, like molecular structures. The GNoME tool has discovered 2.2 million materials. It has simulated 2.2 million materials. That number is true. It's also not highly applicable. Only 380,000 of those are actual stable materials. Of course, all this research has been released. And those 380,000 stable materials do include potential candidates for circuit boards, for battery alternatives, for loads and loads of different use cases. So the discovery of these materials has been massively accelerated with deep learning. However, the actual assembly and use of these materials and the testing of these materials and discovering whether or not these materials are easy to create or are actually useful and do have these theorized properties will be left up to researchers. So all of this data, these hundreds of thousands, millions of materials have been shared with the scientific community, and now it's up to the scientific community to decide which, if any of these materials, to actually try synthesizing and constructing and testing. It will be a while before we have the types of intelligent AI required to actually test assembly of these sorts of materials. However, it's still really interesting to see scientific experts combining forces with machine learning experts to develop models for these kind of edge use cases where AI and cutting edge science can complement each other. That's all for this week. If you enjoyed, please subscribe and we'll have another episode for you next week.